Hello everyone, it's me Arvind catching you on another Tutor Edu's lecture video. In this lecture video, we are going to discuss the differentiation chapter. By the way, we are still discussing the application of differentiation subtopic, and within this subtopic, we are moving on to the part 3, which is the maximum and minimum value. Okay, by the way, I've already completed the part 1 and part 2 within the application of differentiation. If you want to take a look at those videos, you can check out at my YouTube playlist. Okay, so let us start our discussion for the maximum and minimum value. Okay, so this maximum and minimum value concept, they are almost similar to the maximum and minimum points. Okay, how is it similar? Okay, let me just explain to you. For maximum and minimum point, you are required to find the turning point first, which means that you need to set your differentiation equals to 0. That means that your first derivative you should set equals to 0. Okay, and which is known as the turning point. Okay, so once you already find the turning point, to confirm that whether the turning point is a maximum point or minimum point, so you need to perform the double differentiation. Okay, if the double differentiation gives you a positive value, that means it's a minimum point, whereas if the double differentiation gives you a negative value, it gives you a maximum point. Similar concept over here, guys. Okay, you still need to perform the first derivative, and then you need to set it equals to 0 to find the respective variable. Okay, and then to confirm that whether that point gives you a maximum or a minimum, you need to perform the second derivative. Okay, similar concept. If it come out as a positive value, that means it is a minimum value. If it come out as a negative value, that means it is a maximum value. Okay, so that is the only minor difference, guys. The minor difference is, before this you are learning about points, coordinates, and now you are learning about the value. Okay, and for this maximum and minimum value, it is best for me to explain using one example. Okay, and this concept is also known as a problems of maxima and minima, guys. Okay, you can check out in YouTube about regarding this topic as well. Okay, so let us start our discussion with this example. So let me read out this question. The diagram shows a circle inscribed in a rectangle KLMN. As you can see here, this is the rectangle KLMN. Okay, and you have a circle over here. The perimeter of KLMN is 80 centimeter. Okay, so take a look, guys. So this is a first information, and by the way, this is a hot question, so please give extra attention to it. Okay, the perimeter of KLMN is 80 centimeter. So proceed to the part A. Show that the area of the shaded region A centimeter square is given by A equals to 40x minus in a bracket 4 plus pi over 4 close bracket x square. Okay, that is for the part A. For the part B, find the value of x and y such that the area of the shaded region is a maximum. State your answer in terms of pi. Okay, so you already finished it, the question, and most of the students, they literally afraid of attempting the hot question. First of all, take a deep breath. Okay, read the question one more time and try to look out some of the informations that you can convert into equations. Remember, information, equation, and then it will lead you to solution. Okay, so try to gather as much information as possible. So from here, let us proceed to the question part A. So what the question part A asks us, okay, they ask us to show that the area of the shaded region A centimeter square is this expression. Okay, by the end of the working, you should get this exact expression. Okay, let us start to solve this. So let me just write here the solution. Okay, delete. Okay, let us start for the part A. So from here, you might think that I will start immediately by calculating the area. Okay, actually what I will do is I will try to write as many information in my working. It will make my calculation easier for me. So let me start with the perimeter of KLMN from here. So as you can see here, KLMN is a rectangle, and they already gave us that the information where perimeter of KLMN is 80 centimeter. That means the sum of the four sides of a rectangle, you should be getting 80 centimeter. Okay, and they already gave us the length and the width is y centimeter and x centimeter respectively. So from here, perimeter KL MN is given as 80 centimeter. Okay, so what you need to do is, since they ask us to find perimeter, okay, by the way, perimeter is the sum of the external length. So x plus with x, okay, x plus with x plus y plus with y, y plus with y. Okay, you plus all the length and the width respectively. Okay, you plus them all, you should be getting 80. Okay, this one I write in terms of the numbers, guys. Okay, this one is for the working purpose. Let me just box this. Okay, perimeter KLMN is 80 centimeter. Okay, let us proceed our working. So from here, x plus x is 2x, y plus y is 2y. So 2x plus 2y you should get equals to 80. Okay, so this equation you can further simplify by dividing the whole equation by 2. So from here you should be getting x plus y equals to 40. Okay, so this will be your first equation. So if you encounter this type of hot question, so try to gather as much information possible, guys. So I'm reminding you this again. Okay, let us do it step by step. Okay, once you already find the perimeter, let us proceed our information for the area. Okay, so as you can take a look at this diagram, you have a rectangle and a circle. Okay, circle you have an unshaded region and you have a rectangle as a whole bigger area. So from here, technically if you want to find the shaded region, what you need to do, okay, you calculate the big area and then you calculate the unshaded region and then you minus them together. So if you minus them together, you should get the area of the shaded region. So that is the concept. Okay, the big area minus the white area, you should get the shaded area. Okay, okay, big area in this case I mean the total area, guys. Okay, don't get confused. So from here, let us proceed to find the area of circle. Okay, the white area. So area of circle. So how to find the area of circle? Okay, so we're going to apply this formula where it is equals to pi r square. Okay, pi r square is the formula to find the area of circle. So let me just box this. Okay, so from here, so you calculate this. So pi, so how to calculate the r? Okay, let me scroll this up. So as you can see here, oops, so as you can see here, the width of the rectangle is x, and within this rectangle your circle is located, which means that your width is same as the diameter of the circle. Okay, that means they are the same. But then in the formula it mentioned pi r square. R means radius. Okay, radius is just the half of the diameter value. Okay, in this case you have your diameter is x, that means your radius will be x over 2. Okay, so pi times with x over 2 square. Okay, so you calculate this, you should get pi x square over 4 centimeter square. Okay, so let me just underline this. So this is your area of circle. Okay, area of circle. You know what, I just write in a short form AOC. 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 Okay, area of circle, short form AOC, guys. Okay. So from here we already find the white region, which is the area of circle. Okay, let us proceed to find the total area. I mean the big area, guys, which is the area of rectangle. So area of rectangle, okay, is equals to length times width. Okay, so from here just write AOR, short form area of rectangle, is equals to x times width y, or you can write y times x also can. Okay, x times width y. So you calculate this, you should get your area of rectangle is equals to xy centimeter square. Okay, so let us underline this. So we have already find the area of rectangle and the area of circle. So the next step will be minusing them both, guys. Okay, since we have wanted to find the area of the shaded region. Okay, so from here, so AOS, area of shaded region, will be equals to area of rectangle AOR minus with area of circle AOC. So area of shaded region is equals to area of rectangle, which in this case is xy, okay, minus with the area of circle, which in this case pi in a bracket, I mean pi x square over 4, okay, close bracket, centimeter square. So technically this should be your answer, but take a look at the question part A. It should be A equals to 40x minus in the bracket 4 plus pi over 4 close bracket x square, but then we only get this. So that means we need to perform one more step in order to get this expression. So I'm going to teach you the one more step. Okay, however, if you leave your answer in this way, your answer is actually incomplete, guys. Okay, it is considered wrong. However, we have already find the perimeter of a KLMN equation here, which is x plus y equals to 40. So the next step what we need to do is we need to eliminate this y equation. So how are we going to eliminate this y equation? So we're going to eliminate this y variable, guys. Okay, this y variable we are going to eliminate by using this equation number 1. So we're going to express y in terms of x, and then we're going to substitute that equation over here. So once we substitute over here, we should be able to get the answer. Okay, so this is the overall idea of this working. So let me write the working over here using equation 1. Okay, so from here you express your y is equals to 40 minus x centimeter. Okay, for the next step what you do, you substitute this 40 minus x over here. Okay, since you already let y equals to 40 minus x, you can substitute this 40 minus x over here. So from here, therefore your area of sector is equals to, in a bracket, x times with 40 minus x, okay, close bracket, minus pi x square over 4 close bracket centimeter square. Okay, so let us continue our working. So area of it's not area of sector, guys, area of shaded region. So area of shaded region will be 40x minus x square minus pi x square over 4. Okay, so for the next step, what we're going to do is this x square and x square, we're going to combine them. So how are you going to combine them? We're going to combine them through the fraction form. Okay, so your area of shaded region will be equals to 40x minus 4x square minus pi x square over this one. We just write normally like this, pi x square, oops, pi x square over 4. Okay, close bracket. So from here, let us continue. So let us factor out the x square and negative 4, I mean the negative, guys. Okay, so from here, let us factor out the x square. So from here, 40x, okay, so it will be, you know what, I just remove this bracket. Okay, now it's better. So now you're going to factor out the negative symbol, so you're only left with, okay, negative x square. So we factor out the negative x square, because why? So here you have the negative symbol, and you can see here x square is common for this two fraction on the top. So we factor out the negative x square, and then you left with 4 plus pi over 4. Okay, we are almost reached our final answer. You can leave your answer in this way, but to be safe side, you can rearrange this equation according to our question given over here. Okay, basically it's just the same. Okay, so your final answer, you can rearrange your answer such that 40x minus, okay, in the bracket, 4 plus pi over 4. Okay, the x square, instead of writing in front, you just placed it behind x square. So we have already proved that the area of shaded region is equals to 40x minus 4 plus pi over 4x square. Or to be safe side, you just write a. Okay, so the AOS you just lift it as a, guys. Okay, you just write it as a, because that's what the question asks us to give. So let me just delete this. Okay, all right. Okay, now it's better. So we can now conclude that the A is equals to 40x minus, in the bracket, 4 plus pi over 4 close bracket x square. Okay, we have already proved according to what our question asked. Okay, so is it correct? Okay, so we have already done with the question part A. So let us proceed to our question part B. So once you already find the question part A, now it will be easier for us, okay, to find the value of x and y such that the area of the shaded region is maximum. So this is the question part B, guys. Okay, so from here, okay, let me just remove this. So a, we write here again, which is equals to 40x, okay, minus 4 plus pi over 4 close bracket x square. Okay, for the next step, what I'm going to do is I'm going to differentiate this with respect to x. So from here you get is dA over dx okay, which in this case will be equals to 40 minus, okay, the 2, move it in front, and then the power you minus with 1, okay. That means that it will become like this, guys, okay, 2 close bracket 4 plus pi over 4 x. Okay, from here your negative 2 will be simplified, become 1, and the 4 at the denominator will become 2. Okay, so let me just change this in this way. Okay, so from here I hope you understand the working, guys. So I literally differentiate, okay, the 2 I times in front, and then the power I minus with 1, okay, and then I simplify the equation. Okay, so from here to find the respective x and the x value, so you set your dA over dx equals to 0. So you set dA over dx equals to 0. Okay, similar like how you find the turning point. Okay, you set your differentiation, that means your dy over dx equals to 0. The same concept over here you apply, you just set your differentiation equals to 0. Okay, in this case 40 minus 4 plus pi over 2 x equals to 0. Okay, let me just copy paste this. Okay, equals to 0. Okay, so the one in the negative I move it to the right hand side, and then I change the form. So from here it will be 4 plus pi over 2 x, so you should be getting equals to 40. Okay, so from here you times the equation both sides by 2 to eliminate the fraction, times the both equation by 2. So from here 4 plus pi x equals to 80. So from here your x will be equals to 80, you divide with 4 plus pi. Okay, so we already find our x value. So let me just underline the fraction and the solution. So once you already find this x value, so the next step is you need to find the y value. So how are you going to find the y value? Okay, remember that we have already find the y equation at the question part A, where y equals to 40 minus x. So you're going to substitute over here. So when x equals to 80 over 4 plus pi, so from here your y will be equals to, wait on guys, y will be equals to 40 minus 80 over 4 plus pi. So from here you combine them into one single fraction. So from here you combine them, so 40 times it 4 plus pi, so from here you get is 160 plus 40 pi minus 80, and then you divide with 4 plus pi. Okay, so you calculate this, you should get your y is equals to 80 plus 40 pi over 4 plus pi. Okay, so this is your answer for y. So let me underline the fraction and the solution. Okay, the question asks us to find the x and y. So technically the question ends over here, but the question mentioned here maximum. So to confirm the area is maximum or minimum, so to check you can perform the double differentiation, guys. Sorry guys, it's lagging. Okay, so to check whether the area will be given is a maximum or not, so you try to differentiate twice. So from here you get d square a over dx square will be equals to, so you perform the double derivative, so from here you get is negative 4 plus pi over 2. Okay, so let's say if the question asks you to find a maximum area, so what you need to do, so if the question asks you to find that, so you need to use this x and value, I mean the x value and the y value that you find in the calculation, you need to substitute it back into this a equation over here. I mean, not this a equation, technically the one we find over here, the a equals to xy minus pi x square over 4 centimeters square over here. So you need to substitute those, and that's how you're going to get the maximum value. Okay guys, so I hope my explanation is clear. By the way, the checking is just for our reference to check whether it is a maximum value or a minimum value. Okay, and based on the checking, it is a maximum value. Okay, so we have already find the x and y, so let me just scroll this up. Okay, that is all for my explanation regarding the concept of maximum and minimum value. So I hope you find this video useful. Okay, if you like this video, so make sure that you give a thumbs up. If you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming AdMaths lecture videos in the future, and not to forget to share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.